Do you believe in life beyond Earth? Thanks to researchers working with the Environmental Molecular Sciences Laboratory, there could be some clues to life on Mars. I'm Dawn Stringer with Bonding Over Science. Let's hear more about humans getting a closer look at the mysterious planet. Have you ever heard of a mineralogist? Well, I hadn't, and I don't know much about the mineralogy of Martian meteorites, so I asked the only mineralogist I know, Kim Tait. Kim, thank you so much for joining us today on Bonding Over Science.
I'm so happy to be here, so thanks for having me.
Of course. Now, tell me a little bit about your background and how you got interested in this type of work.
Sure. So I was one of those kids that picked up rocks on the ground. I was just always really excited about rocks, and that was very weird to my family, and they didn't know why I was so interested in rocks. But I think some of those fundamental questions that I had as a child still sort of ring true today. I've always been very interested on how different minerals have formed, why there's certain colors, why there's certain shapes, why there's certain, all sorts of different properties of minerals. And I think that's just sort of been a theme throughout my my education and through my experiences, is just asking those kind of really fundamental questions about why things are the way they are. So I have a PhD from the University of Arizona in geology, geosciences, with a specialty in mineralogy. And I've used those skills that I have to, ask questions not only about our planet, but also from other planets, other asteroids, other parts of the solar system that I've been really interested in. So yeah, I'm, the project I'm working on is on Mars and how Mars rocks have formed and why they're there and sort of their history. And I think some of the skills that I've learned throughout my education is just sort of understanding how things work and are built. And that's what I do with all of my projects.
So there hasn't, to my understanding, you can correct me if I'm wrong, there hasn't been a lot of human interaction on Mars. So why Martian meteorites?
Martian meteorites are the only samples that we have from Mars right now, and we are currently working on a project to bring back samples in 2030s, like early to mid 2030s. So until that time, and even planning that mission, we need to study what we have, and that is in the form of Martian meteorites. So Martian meteorites are materials from the surface of Mars that have been launched off the surface by a, sort of an impactor, has removed some of the material that has gone up into the atmosphere outside of Mars' gravitational pull, and then it has crossed Earth's gravitational pull and brought it into to our planet. Now it has to survive through our atmosphere. We have a very protective atmosphere, which is a very good thing for life. It keeps us really safe, but every once in a while, material does land on the surface of our planet. We are almost 3/4 water, so much of it goes into the oceans and in lakes or in places where it's unrecoverable. But if we're really lucky, we are able to recover this material, and then also lucky to get it to an institution like the ROM, into a museum where people can study it and access it for these investigations. So here at the institution that I work at, which is the Royal Ontario Museum, we have one of the larger collections of Martian meteorites. And so I have them here, and I'm able to study them and sort of ask some of the fundamental questions of, why did these rocks form? How did they form? How old they are? All these kind of questions. And I use this sort of toolkit that I've learned throughout my education.
Why would you say these fundamental questions are important?
No, it's a good question. So what's good about our planet for life is that it's a very dynamic planet. We have volcanoes, we have plate tectonics, we have water, we have freeze-thaw cycles, we have all these activities happening on Earth, which is great for life, but it is also a great recycler. It takes away the rock's history of sort of its origin, how it formed in the beginning. And so some of the oldest rocks we have here on Earth are in the range of, 3.8 billion, but we think the Earth is about 4.6 billion. So we've lost this, this really early part of our Earth's history. So if you think about it like, a historical book, we've ripped out the first 2 chapters of the book, and that's where you get all of the buildup of all the characters, all of the different actions and stuff. That always happens in the introduction of your book, right? So we don't quite understand how our planet formed, what it looked like in the very beginning. We don't understand a lot of the processes that have gotten to, form these rocks. But we have a planet right next door, which is Mars, and it seems to have sort of a very similar history starting, how it started out. It has volcanoes. We see features on the surface that look like water has been present on the surface of Mars. But something happened to that planet along the way, and it's sort of frozen it in time. And so if we study some of those rocks, maybe we can learn a little bit about that planet. But I think it has a really good relationship to our planet in that, something has changed so that it's not geologically active anymore. There is no more superficial water. Why did that happen? How does that relate to our planet or not? And, asking that fundamental question is there life out there in the solar system beyond Earth?
Do you have any suspicions on what may have happened?
Well, we only have, small little sampling of the surface of Mars. So, we've sent a lot of missions there to study, the atmosphere, study the gases that are present. We are looking with rovers right now, taking, images and taking, scientific measurements. But what's, I think, going to be really the key part of Martian research is bringing material back from the surface. So once we start getting rocks from, this is called Jezero Crater. That's where they've landed, and that's where they're recovering material. We're going to have some sedimentary rocks. We're going to have some different types of rocks that we have right now. What happens with the process of getting the rocks here is only the sort of the strongest and the most competent rocks can actually make that journey from Mars to Earth. So in that process, we're losing a lot of, different types of rocks that I think would tell that big story about what happened to Mars. But we can see processes of active running water on the surface. So there's all these processes that were occurring at some point. And, we have some ideas of why that happened, but I don't think we have the full story yet.
You mentioned suspicion or some evidence that may have shown that there could have been life on Mars. That's something that a lot of people are interested in. Can you elaborate a little bit on that?
Yeah, of course. So, I think, a real fundamental question is, are we alone? Are we, life here is very vibrant and, we've had, long history. But as we go explore not only our own solar system, but other ones, as some of these images from the James Webb Telescope, even this week, have shown that we're seeing these exoplanets, so planets that are very, very far distance from us, having all the conditions that could be correct for life, as we know it. And so we have to be really careful there that, we don't want to narrow our view on life as only being like us, right? We need sunlight, we need oxygen, we need, all these conditions for our life to thrive. But, as we've explored the bottom of the ocean, for example, we find life that doesn't need light. And, that was even not that long ago when we made those discoveries sort of in the 1980s, where it's like, oh my goodness, there can be life in different environments. So we need to be really careful that we are very open to thinking about life in different forms. But yes, I think it would be hard to believe that, there wouldn't be some other conditions somewhere in, out there that would have all the conditions right to be able to have some sort of life. And, I always show a slide in my lectures, showing, Marvin the Martian. I don't think we're expecting to find that on Mars, but certainly, maybe some bacteria or some, simple cell organisms. I think that is completely possible. Is it alive now? Probably not. So we're kind of looking at life forms that might have survived at some point in the past, but I think that would really shape, how we think about life in general if we were able to find life somewhere else, especially on Mars.
Has there, in any other planets in our solar system, been confirmed any kind of life, bacteria, microorganisms on other planets yet?
There have been some manuscripts that have thought there has been life, but they've been more recently refuted that was probably not the case. And so there's been a lot of care and precautions taking in preparing for the Mars sample return mission. So when the material comes back from Mars, it will have to go into a biosafety level 4 facility. And so this is how we would handle COVID or Ebola or, really, pathogens that would be dangerous to Earth. And we're doing that out of precaution to make sure that we do not inadvertently introduce, sort of a alien life form into society here. But also, I think it's really important to protect us from the, rocks from us as well. We don't want to contaminate these samples from any of our biological materials, because if we do find signs of life, we want to make sure that that is actually from another planet, not just from our hands or from sneezing on it or, anything that we're doing to contribute to these. So I think it's a sort of a two-way street of making sure that any scientific discoveries that we do get from these materials will be definitely from extraterrestrial sources. So yeah, there is a lot of care and planning that is going around that, and sample contamination is a big one. But no, I don't think there has been anything that has been definitive at this point that there is life somewhere else in the solar system.
You talking about what the process might be if something was found extraterrestrial reminds me of Independence Day.
Right. There's been a lot of movies about this, absolutely. And then certainly with, in the world we've lived in for the last couple of years of labs and, of having dangerous materials around. So we have to be very cautious in talking about this and not scaring the public. And that's something that has been really important in sort of our messaging as well, is that we're almost being over, protective of Earth. But I think it's the right call until we can rule out any dangers to Earth, but that will cost a lot of money and a lot of time, and we've been planning this already for years and years and years, and people are really surprised that we're working on this so early, but because the material's not coming back until 2030s, that's so much time, but really it's really important to do this correctly, and I can't wait to get my hands on those samples for sure.
I love the idea of not wanting to scare the planet unnecessarily without the right information, but I have to ask if you believe in aliens.
Well, again, so back to the Martian thing, no, but I do believe that there is the capability of having life forms out there, absolutely. I think that would be completely reasonable to believe that there are, we're seeing exoplanets with, methane. Well, how would they form methane? There has to have been some sort of process that is, creating these gases. They find water out there. We're finding, oxygen. We're finding all the little ingredients that we need to seed life. So, yeah, I think it is very possible. But, time will tell. And, I think the way to really identify if that's possible is to understand our solar system, and we do that by studying the materials that are coming to us for free from these natural processes that are happening, and getting to know them. And I think if we look at the Apollo mission, these rocks were brought back 50 years ago, and we're still making incredible discoveries and measurements on these rocks that have been on our planet for 50 years. So that gives you an example of how much we still need to learn about our environment, and we're still learning about our own planet. There's places where we don't even understand how our moon formed, for goodness sakes. So these really fundamental questions are what drives some of my interests, but I think a lot of researchers out there for sure.
I'm excited to see you further your research. How is EMSL going to help you do that?
Well, EMSL has just been such a blessing in so many ways. What I love about EMSL is that there is sort of like a one-stop shop. There's a lot of instruments that exist in the world that we can access. But what EMSL does so well comparatively to other places is that it has all the instrumentation in one spot, And these instruments can work together, and the scientists can work together to solve a problem or to answer a question. And that's a really unique feature about EMSL that I'm so grateful for. There is just a group of scientists that are just as eager to learn and as eager to talk about science as me. And so, you sort of arrive, or even before you arrive, you're having these discussions to, I have a question, how are we going to do that? And then all these experts are coming together and they're like, have you thought about this, or have you thought about that? And, maybe I have it, so they're even bringing some sort of thought process to the research program before I even arrive, which is excellent. And then when we do arrive and come on site, really that flow of one instrument to the other is seamless, and everybody is working as a group, as a team together, instead of having one data set from X lab and then having to fly around the world to another place. It's just, we don't have to do that with EMSL. And so I have been just so completely humbled by not only the instrumentation that is available, but some of the staff and some of my interactions with them have been just absolutely excellent.
Well, you mentioned some of the instruments. Which instruments have helped you progress your research?
I was thinking you're going to ask something along those lines, and I don't want to say which one's better because they're all good. So I would say what brought me in to apply was the atom probe that is available at EMSL. But what has progressed as I've used the atom probe is some of the relations to the other instruments, like the nanosims, which I have no experience with whatsoever. And but talking to the staff scientists there, they're like, if you did this and this might help you understand this more, and using these other instruments. So has broadened some of my thinking and some of my approach to some of the problems. So I have greatly benefited from those discussions. So atom probe was the hook, but certainly now getting into more of the nanosims and some of the TEM work that I've been doing has been extremely beneficial.
So how will this research impact society and benefit society in the future?
Yeah, so that's a really good question. There's always sort of direct benefits, and then there's sort of indirect. And it's interesting to see the indirect effects. I think more so than the direct. Sometimes people say, well, how do you you're not a doctor, you're not saving lives, how is that relevant, or why is that important? But there's a lot of things that spin out of sort of basic research, right? And I think that's what's really exciting to me is, like if you just even look at the Mars sample return, the billions of dollars are being invested. So all of the jobs that are being created, but also as we explore space and as we go further and further out there, there's going to be all these, they're going to have to push the limits of telecommunications. They're going to have to push the limits of oxygen generation. They're going to have to push the limits of, suits and materials. Kevlar came out of, some of the missions from before. So, and, those are just some examples, but there are so many indirect examples of things that are going to come out of not necessarily directly of my research, but sort of as the process goes on with teams of people exploring. And I think that that would be what I would call this is sort of some of the research I do is sort of the basis for exploring our solar system.
What would you say to other researchers who are interested in submitting a proposal to EMSL?
So what I would suggest is to reach out to the staff scientists that are present at EMSL, because sometimes starting a proposal might be intimidating. If you have an analytical technique that you're interested in, I would recommend reaching out to sort of the scientist that's involved or who runs it mostly, and touch base with them and start to have that dialogue and that conversation about the instrument, because I think what came from that is the tangential connections to the other instrumentation that's there. And then maybe you can even have the opportunity to test a sample. So, send one sample out for, one data point or 2 data points, just to sort of show that it's capable, or you're able to get this data and sort of the significance of the data that is collected. Because I think that was really key to the proposal that we put in, was having that sort of test before, to show that everything can work and that we are able to be successful with the data that we have.
Well, Kim, this is a question that I love to ask people. Are there any unanswered scientific questions that keep you up at night?
Keep me up at night. Well, I sleep quite well, so I wouldn't say keep me up at night per se, but I think I just really get excited about understanding how things work. And I think that's just like a fundamental, kind of basic question, like why? Those whys, kind of as a toddler have just always been there for me. And if I can, do one little part to sort of, push the ball down the field a little bit for some of these questions, I think that's really exciting to me. And, I think if we can understand more about Earth is really exciting. How we formed, why are we here? Why is there life? All these big questions. I think that is worthy of waking up in the morning and jumping out of bed and getting to work really early. So I think as long as you're doing something that really excites you and is fun and challenging, that it's worth doing. So that would be my answer. I don't stay up at night, I would say, but get up in the morning and get really excited, yes.
Well, Kim, this has probably been one of the most interesting conversations I've ever had, and I definitely want to continue to follow your research and where it goes. Where can listeners find you online and maybe keep up with your endeavors?
I have a website, taitelab.com, so that would be a good place to look at some of our more recent research and stuff. And I'm on Twitter, I'm on, LinkedIn, so definitely find me and follow along. I try to post regularly about what's happening and what's exciting in space, and happy to have a couple more followers for sure.
Thank you for listening to Bonding Over Science. I'm Dawn Stringer for the Environmental Molecular Sciences Laboratory. We don't have time to cover it all, so don't forget to check out emsl.pnnl.gov for a full article on this topic featuring who I spoke with today. And don't forget to follow us on all social media platforms for the latest and greatest news coming from EMSL. EMSL is a Department of Energy Office of Science national user facility that accelerates scientific discovery and pioneers new capabilities to understand biological and environmental processes across temporal and spatial scales. EMSL leads the scientific community toward a predictive understanding of complex biological and environmental systems to enable sustainable solutions to the nation's energy and environmental challenges. If you're interested in working with EMSL, learn more at emsl.pnnl.gov. That's emsl.pnnl.gov.